Data Scientist Roadmap in 2024. 1. Introduction to Data Science. Begin by understanding the core concepts of data science, which involves extracting insights and knowledge from data to make informed decisions. Explore the applications of data science across various industries, such as healthcare, finance, marketing, and technology. Learn about the typical responsibilities of a data scientist, including data collection, pre-processing, analysis, modeling, and interpretation of results. 2. Mathematics and Statistics Fundamentals. Refresh your knowledge of mathematics, including algebra for manipulating equations and calculus for optimization techniques. Dive into linear algebra to understand vectors, matrices, and their applications in data manipulation and machine learning. Study statistics concepts such as probability theory, probability distributions, hypothesis testing, and regression analysis, which form the backbone of data analysis and modeling. 3. Programming proficiency. Choose a programming language like Python or R, which are widely used in the data science community. Learn the basics of the chosen language, including variables, data types, loops, conditional statements, and functions. Gain proficiency in libraries and frameworks commonly used in data science, such as NumPy, Pandas, and scikit-learn for Python, or dplyr and ggplot2 for R4. Data manipulation and cleaning. Understand how to acquire, load, and pre-process data from various sources such as CSV files, databases, APIs, and web scraping. Master data manipulation techniques using libraries like Pandas in Python or data frames in R, including filtering, sorting, grouping, and merging datasets. Learn data cleaning techniques to handle missing values, outliers, duplicates, and inconsistencies, ensuring the quality and integrity of the data for analysis. 5. Data visualization. Explore data visualization libraries such as Matplotlib, Seaborn, Plotly, and Bokeh for Python, or ggplot2 and Shiny for R. Learn to create a variety of plots, including histograms, scatter plots, line charts, bar plots, and heat maps, to effectively communicate insights from data. 6. Machine learning fundamentals. Dive into the fundamentals of machine learning, which involves training algorithms to learn patterns and make predictions from data. Understand the difference between supervised, unsupervised, and reinforcement learning, and explore common applications of each type. Study various machine learning algorithms such as linear regression, logistic regression, decision trees, support vector machines, SVM, k-nearest neighbors, KNN, and clustering algorithms like k-means and hierarchical clustering. 7. Model evaluation and validation. Learn techniques to evaluate the performance of machine learning models using appropriate metrics such as accuracy, precision, recall, F1 score, ROC curve, and AUC-ROC. Understand the concepts of train-test split, cross-validation, and hyperparameter tuning to ensure the robustness and generalization of the models. Gain insights into common pitfalls and challenges in model evaluation, such as overfitting, underfitting, and data leakage, and learn strategies to address them. 8. Feature engineering. Explore feature engineering techniques to extract meaningful information from raw data and improve model performance. Learn methods for handling categorical variables such as one-hot encoding, label encoding, and feature hashing, as well as scaling numerical features using techniques like standardization and normalization. 9. Advanced machine learning topics. Deepen your understanding of advanced machine learning concepts such as ensemble methods, including random forests, gradient boosting machines, GBM, and XGBoost. Explore neural networks and deep learning architectures such as feed-forward neural networks, convolutional neural networks, CNNs, recurrent neural networks, RNNs, and transformers for natural language processing, NLP. Gain insights into specialized techniques for handling specific data types and tasks, such as time series analysis, image processing, text mining, and recommendation systems. 10. Real-world projects and experience. Apply your knowledge and skills to real-world data science projects that address practical problems and challenges. Participate in Kaggle competitions, where you can collaborate with other data scientists, explore diverse data sets, and develop innovative solutions to compete for prizes and recognition. 11. Continuous learning and professional development. Stay updated with the latest trends, tools, and techniques in data science by regularly reading research papers, blogs, and articles, and following thought leaders in the field.